Hello students, welcome to JCE Connect series of lectures. So in previous lecture, we have discussed about the design procedure of a Pelton wheel. So in this particular session, we will solve one design problem so we can understand the procedure of uh, Pelton wheel design. So as we discussed in previous lectures, the design of Pelton wheel means the following data is to be determined. So that is, you have to determine the diameter of the jet, then the diameter of the wheel, capital D, then the width of the buckets, which is given by 4 to 5 times of diameter of jet, depth of the bucket, which is given by 1.2 times of diameter of jet, then the number of buckets on a wheel, it will be given as z equal to d divided by 2 into d. This the ratio d by d is nothing but a jet ratio plus 15. Then the size of the bucket means the width and depth of the buckets are to be calculated. Then let us take one design problem, that is design a Pelton wheel, or a Pelton wheel is to be designed for a head of 60 meter when running at 200 rpm. The Pelton wheel develops 95.6475 kilowatt shaft power. Then the velocity of the bucket 0.45 times the velocity of the jet. Take the overall efficiency as 0.85 and take CV value as 0.98. So these are the datas given. So let us first write the given datas. So the datas given here are the head available to supply water into the turbine, that is 60 meter, and the speed of the wheel or a rotor as a 200 rpm, it is given. So we have to maintain this much, of a power, sorry, this much of a speed. Then the shaft power to be uh, generated as 95.6475 kilowatt. Then the velocity of the bucket to be taken 0.45 times the velocity of the jet. Then the whatever the Pelton wheel we design, that should give overall efficiency of 85%. Means after considering all the losses, the finally it should give 85% efficiency at least. Then the CV value should be 0.98. So for these given datas, we need to design the Pelton wheel. So the design of Pelton wheel means, as I discussed previously, that is the design of Pelton wheel means to find the diameter of the jet D, then the diameter of the wheel D, capital D, then the width and depth of the buckets and the number of buckets required, that is optimum number of buckets required on the wheel. That is the design of Pelton wheel. So to calculate these things, let us first calculate what is the velocity of the jet and diameter of the wheel, capital D. Calculate the velocity of the jet. The velocity of the jet can be calculated, that is actual velocity of the jet, CV into root of 2gh. So in this we know the value of CV and we know the capital H. Substitute the values here. G is acceleration due to gravity. Then we get the velocity of the jet as 33.62 meter per second. Then once we know the velocity of the jet, then the bucket velocity can be easily calculated, because the bucket velocity they have mentioned in the problem, that should be taken 0.45 times the velocity of the jet. 0.45 times the velocity of the jet. That is u equal to u1 equal to u2, that is 0.45 into v1, that is 0.45 into 33.62, so which gives the bucket velocity as 15.13 meter per second. But as we know the peripheral velocity, this u is peripheral velocity, that can be given as a pi dn by 60. This u is that because the rotor will be like this. These are the buckets. So then the bucket initially takes the motion, linear motion, then it starts rotating. Then this rotational velocity can be given as 5 dn by 60. From this, because we know the value of u, we know the value of n, then the d can be easily calculated. That is whatever the what is the diameter of wheel required. So the diameter of wheel required will be 1.44 meter. Okay. Then so uh, the diameter of jet can be calculated easily. To calculate the diameter of the jet, we need to calculate first what is the discharge, total discharge. To calculate the diameter of jet, the overall efficiency formula, as we know, the shaft power by water power. Shaft power, that is the power at shaft divided by water power, that is W into Q into H, where W is the specific weight of the water, Q is the discharge, and H is the head. So in this, the power is given, specific weight, that is 9.81, and Q is the unknown, and H is given. So from this we can easily get the value of Q. So value of Q we have obtained as 0.1912 meter cube per second. I hope you understood this one. So you have to remember this overall efficiency formula, that is shaft power by water power. Shaft power by water power. So from this we can get Q, value of Q. So once we get the value of Q, then next it is the next you have to calculate the discharge Q. Q, we know the formula Q equal to area of jet into velocity of jet. The area of jet can be given as pi by 4 into d square into v1. Substitute value of Q here, we get the diameter of jet as 0.085 meter, 85 millimeter. Then the size of the buckets, that is means the width of the bucket to be calculated, and the depth of the bucket also to be calculated. That is, this is the plan of the bucket. So we need to calculate this width of the bucket. We also calculate the groove width, and the radial distance can also be calculated, and also the depth of the bucket, that is this depth. Sorry, the depth is this one. The depth of the bucket to be calculated, C. So width of the bucket to be considered here is 5 times of d, or you can consider 4 times of d. That is, it is generally varying between 4 to 5 times of diameter of jet. Then we get as a 425 millimeter. Depth of the bucket is 1.2 times depth of diameter of the jet. Then we get as 102 millimeter. Even you can also calculate the groove width. That groove width can be taken as a 0.8 times of d, generally 0.8, and that also can be calculated. But if we calculate the width and depth, that is sufficient for the design of a Pelton wheel. Then the number of buckets on the wheel can be calculated by using the formula. So that is Z equal to d by d, that is this one. This will be actually 0.5 times of m plus 15, where m is the jet ratio. Okay, then substitute the values here. We get the optimum number of bucket required. The optimum number of buckets required are 24 numbers. Optimum number of buckets required is 24 numbers. I hope you understood this design. Let us take one more problem. That is the problem given here as this one. The following data relate to a Pelton wheel. The head given as a 72 meter. The speed of the wheel is 240 rpm. Shaft power of the wheel is 115 kilowatt. speed ratio 0.45, coefficient of velocity as 0.98, then the overall efficiency 85%. Design the Pelton wheel. So many a times the in exam the problem will be given like this: the following data is related to Pelton wheel. So the data will be given like this, and they'll ask you to design the Pelton wheel. As I discussed previously, the design of Pelton wheel means you have to calculate the diameter of the jet, diameter of the wheel, the number of buckets required, how many number of jets are striking, and uh, the power that is the shaft power will be given, then the RPM will be given, everything will be given. So for that you need to design the Pelton wheel. Okay, so here let us write first the given data, that is head available at inlet of the turbine is 72 meter, then the RPM of the wheel is 240 RPM, then the power, that is shaft power, of considering the overall all the losses, finally the power reaching at shaft will be 115 kilowatt, or it is generating 115 kilowatt. Then the speed ratio will be 0.45, the CV is 0.98, and the overall efficiency is 85% to be achieved. So for that, uh, so let us calculate first the diameter of the wheel. So the diameter of wheel is capital D is 60 into U divided by pi n, but where the U is what? The rotational velocity or peripheral velocity Ku into root of 2gh. So this is we know this formula very well. So use this formula. Ku is the speed ratio which will be given. If not given, you have to assume this one. Generally it will be given, and if not given, it is to be assumed between 0.43 to 0.48. Then we get, then substitute here, we get the diameter of the wheel. Then calculate the diameter of the jet, because we know the overall efficiency formula, shaft power by water power. So this is nothing but shaft power divided by water power. Shaft power is given 115 kilowatt. Substitute the value of W here, and the Q is unknown, H is known. Then calculate Q. This much is the discharge coming, and then we know Q equal to A into V1. Substitute A is pi by 4 d square CV root of 2gh. Then from this we get the diameter of the jet. Then once we get the diameter of the jet, then the size of the buckets can be easily calculated. So size of the bucket means, as I said, this is the bucket. We need to calculate the width of the bucket, then the groove length or radial length. The width of the bucket will be the 4 to 5 times of d, and the length, the radial length will be 2.4 to 3.2 times of d, and groove length will be 1.1 to 1.25 times of d. And depth of the bucket can also be calculated, that is 1.2 times of d. Then calculate the size of the bucket. The size of the bucket will be generally taken 5 times of d. Then substitute the value of d here, that is diameter of jet, we get as a 407 millimeter. The radial length of the bucket L can also be calculated 2 to 3 times of d. Let us take the 2.5 times of d, then we get as a 203.5 millimeter radial length of the bucket. Then the depth of the bucket can be generally taken, that is between 0.8 to 1.2 times of d. Let us take 1.2 times of d, we get as a 97.68 millimeter. Then the number of buckets on the wheel. So this is the formula to be used. The optimum, we get the optimum number of buckets on a wheel, that is d divided by 2d plus 15. We know the capital D, we know the small d. Substitute here, we get the optimum number of buckets as 24 numbers. So optimum number of bucket means this is the wheel. So the number of buckets required on this wheel, so we can generate the power whatever mentioned, so that much of power can be easily generated. These are called optimum number of buckets. So okay, so 24 number of buckets we required. So I hope you understood this problem. So like this you have to design the Pelton wheel. So design up, I'll repeat once again, the design of Pelton wheel means, so calculating the diameter of the jet, calculating the diameter of wheel, then the number of jets to be calculated, then the number of buckets to be calculated. So uh, if we calculate these all parameters, so we can say it's a design of Pelton wheel. Okay, so this kind of problem generally will be asked for 15 to 20 marks. So you can easily get 15 to 20 marks so in this problem. Okay, thank you.